Calculating empirical formulae is first taught at GCSE, but from marking one of last year's AS papers, I know that many A-level candidates still struggle with this. So let's take a look at how to do it. First of all, the definition is, for an empirical formula, the lowest whole number ratio of the atoms present in a molecule. Which differs from a molecular formula because the molecular formula tells you the actual number and type of atoms which are present in that molecule. And an example of the type of question you might get is this. Hydrocarbon X has molecular mass of 78 grams per mole. It is found to have 92.3% carbon and 7.7% hydrogen by mass. Calculate the empirical and molecular formulae of X. So the first thing we do is we try to take the numbers that are useful out of the question. And in this case it's the 92.3% carbon and 7.7% hydrogen. And we note that both of those add up to 100% in total. So there's nothing else that's present, but also it is a hydrocarbon, so we should only have hydrogen and carbon. The 92.3% goes there, the 7.7 there. We're working in columns, and it doesn't matter if we're given a percentage or if we're given an actual mass, we still work through this in the same way. So the first step is going to be to divide by AR, the relative atomic mass. So I'm dividing that by 12, and I'm dividing that by 1. I can do that one straight off, but the 92.3 over 12, 7.69. Now already I can see that that looks like it's going to be a one-to-one relationship. But what I'll do for step 2 is divide by the smallest number from step 1. So let's just go through this in full. The 7.69 over 7.69 is going to equal 1. The 7.7 over 7.69 is also going to basically equal 1. And because we're looking for a whole number ratio, we are not going to worry about the fact that that should be 1.00 something. The third thing I need to do is actually write the formula. So this is a one-to-one ratio, so that means that it is CH as the empirical formula. But the question also tells me that the molecular mass is 78 grams per mole, so I need to do something different here now. And the empirical mass is of CH, which is equal to 12 plus 1, which is 13. So to work out how many units of that I have in the actual molecule, I take my 78 and I divide it by 13, and I should get 6. So that means that the molecular formula is equal to 6 times CH, which is C6H6. So that's benzene. One thing to note is that for the sake of the examiner, do try and get this calculation in. And that 78 hasn't come up magically, that was the MR of the substances given in the question above.